Okay, so we're going to derive Pascal's rule, which states that n choose k plus n choose k minus 1 is equal to n plus 1 choose k, where k is between 1 and where, of course, k and n are natural numbers. So let's go ahead and start the proof. So we're going to have n choose k plus n choose k minus 1. We know this is equal to n factorial over k factorial n minus k factorial plus n factorial over k minus 1 factorial, and then this will be n minus k minus 1 factorial. All right, so this is equal to, n factorial over k factorial n minus k factorial, right, plus n factorial over k minus 1 factorial times n minus k plus 1 factorial, right? Because we have to distribute that negative. So now what I see here is I can actually get a common denominator between these two fractions, right? Or these two rational numbers. If I multiply top and bottom here by k, I get k factorial, right? And if I multiply top and bottom here by n minus k plus 1, I get n minus k plus 1 factorial here. So I get what I want. So I can do n factorial times n minus k plus 1 over k factorial n minus k factorial, and then n minus k plus 1 plus, and then I could do n factorial times k over, well, let me fix that really quick, over k minus 1 factorial times k times n minus k plus 1 factorial. And this will give me n factorial times n minus k plus 1, right? Over, so this will be k factorial times n minus k plus 1 factorial, right? Because I have n minus k factorial times n minus k plus 1, which gives me n minus k plus 1 factorial. And then this will give me n factorial k all over k minus 1 factorial times k is just k factorial, and then I have the n minus k plus 1 factorial, giving me that common denominator. So now I can combine the numerator. So this is n factorial times n minus k plus 1 plus n factorial times k, and that's all over k factorial n minus k plus 1 factorial. So now this gives me, so I will factor out the n factorial. So n factorial times n minus k plus 1 plus k all over k factorial n minus k plus 1 factorial. So now reducing that top, this will give me n factorial times, so this will be n plus 1, right? Over k factorial, n minus k plus 1 factorial. So remember, I wanted to find n plus 1 choose k. So let me go ahead and write that down here. N plus 1 choose k. And let me start going backwards a little bit, right? So this is the same thing as n plus 1 factorial over k factorial, n plus 1, right? N plus 1 minus k factorial. Well, that is what I have here, right? N factorial times n plus 1 is n plus 1 factorial, and n minus k plus 1 is the same thing as n plus 1 minus k factorial. So this happens to be this, and this is equal to this, right? So we've proven that n choose k plus n choose k minus 1 is n plus 1 choose k. And that is the proof.